I'm here to talk about Houdini. It's a sunny day. Hey, boys and girls, this is Nero, which makes me in a good mood. When I'm in a good mood, I want to talk about Houdini. Yeah, that's me. And first of all, I'm going to ask you a question. Did you ever fill up tank? It's not like you want to fill up the tank, but with the source outside the container. I mean, inside the container. Here's our little secret. It's all relied on a fancy little word, which is called divergence. Mhm. Okay, what is divergence? Let's talk about divergence later. First, I would love to show you what do I mean. But it's going to be wrong. I'm going to call it a wrong method. Alright? Let's make our container. Copy here, paste. Oh. Paste it here and divide that by 2. Why question mark? Go up and choose the face and delete it. All is true. Let's extrude that a little to the back. And the collision source with the null. It's a good habit to name everything in case you forget it later. Or drag. DB. This is our container, yeah, collider container, you name it. And then, of course, we gonna need our source. I'm not talking about here. This is simple. Right? It's going to fill up the tank. But what if our source lies here? Right, almost there. Delete stop source. Not enough particle, I guess, but we can change that later. Stop network, of course. Go in. What do we need? Gravity. Go to the first frame. Leap object, because this is a don't have to say. This is Flip simulation. Go to particle visualization, change it to particle. First, flip solver, that's what we're gonna need. And we want a source. We want a source from first context and initialize that. Say source flip. This is our little particles here. I'm going to crank it up, maybe like 0.2. I'm not sure. See, easy enough. Tiny enough. Next. This bounding box is huge. Shrink it way down. Oh, what am I doing? I'm going way down. Because I think that's too much for us. We don't need to spend too much power on that. Almost here. Here. I'm not sure. Maybe 1. Anyway, leave it there. I'm going to fetch our collision. Use volume collision. We want to use the volume sample. It's faster, way faster. Yeah, we get our little thing. See the result. We're going to go to the side view. You see, it's not going to fill up the tank. I keep saying tank is actually a container. It's not going to fill up the container. That's the problem. Let's do another test. Let's raise it up around the middle of the container. Let's see. It cannot go beyond our source. That's the problem. Then how do we fill up the tank? You just go back. Yes. The secret, little secret. our little solution, I should say, supposed to be divergence. Yeah, this is today's topic. Then what is divergence? It's a really important field for simulating or calculating the fluid simulation. If you want, you can check out all these articles. It's crazy. I don't even understand all these symbols, for example, like that. What is that? I'm not sure, but suffice to say, I tried to figure out the mathematical stuff behind the scene, but I couldn't. So I'm going to give you a simple explanation, like this picture. It's a how to say? It's a scalar number on particles. It has a negative number and a positive number, and in the middle is the zero around here. Simple explanation would be when this is a negative number, the particle is going to be sucked in. On the contrary, it's going to be pushed out. That's how it works. For example, see, we got all these particles. We got one dot here, another dot here. They're going to push each other. If we're going to give it if we're going to give it a positive number, they're going to push each other, which means they will try to stay away from each other, which can give us a space between them. And how to use it? Yeah, eventually it's going to be a field. But the solver is going to read it from the point, which means it's an attribute on the point. Then what is our point? Yeah, this is our point. Let's actually create call this one create divergence. Let's name it divergence. Let's give it a number, like 1. Did it work? Let's see. I'm going to disable display. Is it working? No. It's not working. Why? If you go to the visualization, here we can check out all this field, the pressure kind of thing. Yes, but scroll down. There's a divergence, but it's grayed out, which means we don't have divergence. But we already said it here. Why don't we have divergence? Okay, just remember, go before is go to the initial data card and check it out here. Then we got our little divergence. T is here. Is it going to help us? Oh, it worked. It rise up. I see that. It rise up like what we expected. But this is not done yet. We still have other problems to deal with, which means I'm gonna show you, but not in this case. Let's go up. This is what I did before. I'm going to steal all these. Come on. Paste it here. Delete all this. This is what I did before. That is my in, and I boolean out to the bottom, and convert that as our source. This is our source. Let's go in first. I think is enough. Okay. It already changed because they're already linked. You have to pick it. Okay. Anyway, this is our glider source. And divergent, I made it 2. Let's keep it as 2. It's asking for group 1. I disable the instance, and I disabled. I deleted the group. Then let's see. It's not going to rise because this is a closed model. This guy is closed, watertight. We need to go here, and the inverse science of Houdini knows, oh, the container is hollow inside but solid outside. Let's see. This time is right. Like before, I'm going to disable that. Like what we expected, exactly. But we are facing another problem. Yeah. You know what? It's jittering. It's blowing my mind. It's here. See, all this craziness, we need to deal with it. We want to decrease it, make a claim when it fills up the tank. Okay, how to do? There is a scale. This is just a multiplier for the divergence attribute. 248 seems cool. I'm gonna say yes, you can be 1 and then just scale down to 0. Is it going to help us? Not sure. Let's see. Ooh, goes up. It becomes 0 here. Becomes 0. But it's still crazy. Okay? It doesn't work. Why? Okay, the little secret, but really important, lies in here. Go into the solver. Control F to search for bait, or you can search for divergence. Now this guy, or this guy above him. This is a particle to field. This is responsible for changing the attribute to field, and it's actually you can see here, it's changing the divergence from the geometry destination to the divergence field. Scroll down. It says set initial. That's the problem. You need to change that to set always. If you're going to keep that as a initial, the number is always going to stay at 2, which is this number. It's not going to change. That's secret number 1. Let's go. The result is much better than before. See, there isn't anything. It's just yeah, very peaceful, which is nice, but it's still problematic. I show you. Why did I say it's still problematic? Let's still go to the side view. Remember the height. Okay, we want it to almost fill up the tank, the container, but it's going down. You see that? Compare this with that. We're losing it. I only got 140 frames. If you give it a longer frame range, you will see it's going to keep lowering. That's the problem. How can we deal with that? Nope. Go to particle separation. Go to separation. Apply particle separations. These somehow does the same thing as a divergence field, but it's not going to explode your particles. It's just to try to keep the distance between the particles, not suck in or push up. Goes up nicely and crazy explosion. See, it explodes around. I believe that's because we don't have enough space for the particles. See? But, another explosion. Okay, anyway, see, check out the end frame. It's already better than before. Before it was like I think before it was like I believe this height, and now is here. It's already better than before. We just need to find the right parameter. And we have another problem, which is all this chaotic movement. How to deal with that? Because we don't want the fluid to explode like everywhere. In order to solve this, we first need to understand it. What's causing it? Not the velocity. Check out the velocity. Can I do it here? Wait. Give me some time. I only want. And can I click it? The other direction here. I want the other direction. Check out the velocity here. Whatever inside, I mean, stay away from the wall. It's much better. But once it reaches the wall, remember this picture, or even better, this picture is going to all the directions. All the directions means everywhere, right? Because for this one, they still have enough space to go up because it's empty around here. But for the particles, I would say nearby the wall, there isn't enough space. How to deal with that? You're still trying to go everywhere, here. But yeah, this dead end. That's what causing the problem. Let's go back. In order to fix this, we need to deal with that. Don't worry, we can still get it back. But not in the soft plane this time. Instead, we can make a soft solver in the dot. We can define the attribute inside the dot, right? Let's say define divergence. In this plane, we're gonna use import field to grab the flip product. We want to fetch that, but we don't want a geometry and val. We only want the surface. Where is it? Yeah, it is here. This is the surface we get. Then let's make a wrangle. We want to modify the particle eventually by that. I'm gonna say give it a name, which means define divergence. The color, because it's important. So we are going to say this equals volume sample. We want to sample the surface. That's the surface. We're going to sample that. Because that's before. Should I? Wait. This is a volume. See, one grid volume. But here's another problem. To be honest, I didn't check. But for safety's sake, I convert that to a VDB. Now, if you're going to see that is VDB, because okay, for those who doesn't know what a VDB is, just think this one. Okay, let me go out, then make a box. Think this one as a VDB. I need to. Oh my god, I need to click it. So we can learn much better. This is think this one as our VDB, whatever on the edge, there's a number which is 0. Good. Say surface equals 0. If it's equals 0, but whatever inside the box, I'd like to use another color. For example, whatever inside the box is less than 0, meaning a negative number. But whatever outside the box, all the outside this box is positive number. With this in mind, then we can just sample the number on the surface. That's why I converted it to AVDB. I didn't check the volume because I'm afraid it's not going to work. Just for safety's sake. So we're going to sample the numbers. Then we're going to say if this is less than, should I say less than? Yeah, it's greater than the threshold. I'm gonna say this to surface. Then your CV gonna equal 0. Let's see that. It's not working because we haven't defined, say, negative 0.1. 0.01. Why we just limited inside, all right? Which means this one's true. This the CD color is just for helping us to find the right position. Then we going to say you're going to have a divergence attribute which equals 2, meaning only the white particles has the divergence equals 2. This way, we somehow isolated the particles around the edge, the walls, right? Let's see, is it going to help us? It seems fine. Let's see the readout and disable the sleep. Somehow still chaotic, even with limited what was inside. What happened here? Come on, give me color. Oh yeah, I disable that. Even if we do it here, that's why we want to go out because I don't forward too much because remember what we had before. Where is it? Enable that again. With this simulation, all these white particles, the blue particles have the divergence field, which isn't what we want. Is going to keep pushing the particles around against the wall. Ooh. Go up. Let's make null here. Go up, copy that, and go in here. You can use a group and back merge. You can say that yeah, we imported that and let's call that how to say in source. Give a name in source group. We are going to enable this one so we can somehow do that for in source, right? Meaning only this point is going to be affected by this whole algorithm. Otherwise, create diver. Am I right? Divergence to 0. Divergence gonna be 0 for the rest of in force group. Oh, this time that's the new result. It's much more better than before. Yeah, maybe specific. The divergence field is being limited here, not around here anymore. So we won't push it out again. That means we're gonna need higher value. What? Okay, there's a new readout. Yeah, it's somehow better. You can see some little bug. I believe you can always crank up the substep and lower the grayscale. Yeah, it's all about finding the correct parameter for your simulation. Yes, we almost there. And I think you already understand what I mean. And that's the solution for traditional dot simulation. Actually, there's another recipe, but I haven't had time to check it, which is using the top level flip. I give a hint. They flip inner. Yeah, it's much better than the traditional dot solution, I think. But how to make it chill down, I haven't figured that out. But yeah, maybe I will see into it once I got time. Anyway, this is our boundary. Still, we want to get it here. Oh, that's not enough for us. Before was 0.8. And the collide. It's not called collider. It's called collide. We drag it here. Flips over. Where is it? Yeah, it is here. It is here. It doesn't have to have anything. This is because we have the same problem like what we had before for inverse sine. Okay. Full of problems because you cannot find the inverse sine inside this stop level dot, right? There isn't any parameter for you to choose that. You can either maybe cut a hole and do what we did. How to say? To extrude it, or you can just invert this. This is actually the collision. Check here. It says collision, and collision is called surface, I believe. Yeah, it's called surface. And I say, oh, we don't have velocity, so we don't need that. We're gonna say surface equal -1. This is what we got now. No, it worked. All right. Let me go to visualization. I don't want to see spheres. Just give me particles. That's what we get. Now, how can we enable divergence? I think I haven't tried this, but yeah, we can try. You know what? I like to do things on the fly because you can understand how I'm struggling. Divergence Let's make it 2 and see. Huh? Why is like that? I don't anything. Oh yeah, it's a display bug. Go up. It's here now. This new version has some kind of bug. Is it going up? Is it enough? Come on, go back. Let's give it 100. No, it's not working. What if we go to the source and make what we did before? Yeah, let's make a soft solver. Connect here. And let's make it simple. Just again, divergence 6. Is it good? Oh my god. Every time I dive into a sub-level doc, I need to reset my UI. It doesn't work. So, meaning it's not going to work like what we did in the traditional doc. Now, how do we deal with that? It's actually simple. During the boundary, okay, this is fully boundary sub. Here is a parameter called boundary. If we're going to choose either one of this, I'm not supposed to say like this. I'm okay. This is what happened if we're going to leave it as none. It will try to sim as the traditional saw does. Okay. But if you're going to try to velocity, it's still not working, right? But unfortunately, we don't have any velocity because this guy isn't moving. But we can give it a normal velocity. It's going to push the particles outward from the normal of the surface, right? See, it goes up. It goes up. That's how you get it. But forget all about this little bug. We don't care about the fun. We care about that for now. Or if we're going to say go up, just choose the velocity. This is the second solution. Why is bothering me? Go to collision. Can I? Don't show collision. It's going to go up like what we did before, and it's not going to jiggle around because we're pushing it upward. Problem is, it's going to say negative. Let's see, crazy. That's why I believe that this velocity is still our best choice. Normal velocity. But the problem we already had, the force is pushing it against the wall, which there will be some leak. Anyway, that's the first choice you can have. Second, pressure. Pressure. For the pressure, let me think. You can crank it up. Is it going to work? Yes. I think it's because of this. And you're gonna need a water level. I'm supposed to see that. Where is it? Water level. Is it working? Oh yeah, I'm supposed to display this. Okay, that's our water level. This can help you to define where do you want, where the water level you want. Say around here. Why is it rotating? I don't know why is it rotating? It doesn't work. Why? Let me check. Sure. Wait, behavior. No. Right there. We're not. We don't even have to activate the hydrostatic pressure. Yeah, another scientific thing. It's not going up. Uh, I'm not sure. It worked before since my last test, but it's not working now. Anyway, you can always check that. I'm not going to do that this time. Maybe next time. After I figure out how to make a claim. Anyway, uh, you these can help you to define the height of your water. That's it. I think. That's for today. We're gonna leave this for next time. For this time, just remember how to deal with divergence and what is divergence, how to play around with it. That's it. Hopefully, there will be another sunny day. And I can be in good mood again. So I can try to figure that out. All right, guys. Like always, I hope you guys find this video useful, and I will see you next time.